Hello, my name is Ivan Gorodinsky.
And I'm Emmanuel Ramini, and this is our project presentation on a deep learning plastic identification model. So first, starting from our motivation, the purpose of this project is to help global communities around the world track the flow of plastic, both generated from their communities and brought to them by like the ocean or water currents. And our technology is being used by a team called Trash to Treasure, whose goal is to, through beach cleanups, which are already the best way to clean up beaches, to document all the trash in an area in order to give this information to local communities in order to better combat local trash, and our tool helps them do exactly that. They're currently using a rudimentary chatbot to try to attempt this task and guesstimate guesstimate to identify what type of trash is in the picture, and our model clearly identifies what type of plastic is in the picture for them. Our goal is to create a lightweight model for this. That way, we're able to send it around the world and everyone can have access no matter with no compute cost or efficiency needed. And it'll help yeah. And then continuing on to our model, Ivan can explain.
Yeah, so to achieve our goals and complete our project, we are fine tuning two real-time object detection models. These models identify and localize objects instantly very fast, and they're both lightweight. As you can see, we're training V8 small and V8 nano. So V8 small is 3 million parameters, and V8 nano has 11 million parameters, and you can see the size difference, 6 megabytes to 22 megabytes. It's basically the size of the files. So these are relatively lightweight models. They're pretty small. And we're training these models because we only have access to like our PCs and phones and stuff like that. And so both of these YOLO models are trained on synthetic pictures created in a lab at San Diego State University. And if you see in the bottom left corner, these three pictures right here above the types of plastic are the types of images they're making. And so these were created in a lab to basically replicate what you might see in the real world. And we are trained on 1,000 pictures. And training these models is a supervised test. So for each image, there's a separate file with each image included with ground truth labels, which explains the types of plastics found in the image and where the plastics are found in the image. And so we're going to move on to the results. And so as you can see with both of these models, we can see that the test precision is very similar. The test recall is very similar. And the model size, though, is significantly different. And so this section right here is explaining the speed on an A4000 NVIDIA GPU. So as you can see, the difference for the V8S, the inference time is a little bit, almost double the time, and the post process is about 9 times. So as you can see, with the speed on the different NVIDIA GPUs, the pre-process speed is very similar, but the inference and post-process speed, there's a huge difference. And we have shown, and these 7 classes are for the 7 different types of plastics. So it's in the bottom left corner. Here's an explanation of those. But yeah, these are the process speeds per class of plastic. And then our summary and conclusion will be explained by Emmanuel right now.
All right, so as you can see, overall, these models perform very similarly. They both perform very well. The lightweight model has slightly lower accuracy, and especially that MAP50, that is a like more rigorous test with an overlap in the images in order to make it a bit more difficult for the model, a bit closer to a real world example. It performs very similarly, and this tells us that there's not much loss by going to a lightweight model. One of the greatest things about the lightweight model is that it has a much lower inference and post-processing speed, and so it can be used much easier on the fly, and is much more useful for people with any type of device to lower compute costs. And this is great information going forward with this project, as we know that when the team goes to develop an app, that they can cleanly go to a lightweight model for YOLO and keep the same accuracy that they had with the larger weight models while making it much more accessible and easier to use. And that is all. Thank you guys so much for listening to our presentation.
Thank you. That